Hello students, today let's discuss Manipur Board Class 9, Exercise 1.1. First let us see question 1. Show that there exists points on the number line not representing rational number. It shows that on the number line there is a point which are not rational number. Which are not rational number means which number? Irrational number. That means irrational number can also be represented on a number line. In order to show this, first you draw XO, X dash. Starting from 0, 0, right side will take positive integer, 1, 2, 3. And then 0, left side will take negative integer, minus 1, minus 2, minus 3. And in here, first let's construct root 2. 0 to 1 will take 1 unit, and in here 1 perpendicular line, that also 1 unit. Same as with this, will take which is perpendicular to x-axis, and you join this hypotenuse. By using Pythagoras theorem, we know that this 1 square plus 1 square equal to 2 square, and hypotenuse 5 means we will get root 2 square, which we have already shown in the introduction. Again, let us take here again 1 unit, which is equal to previous unit length. This 1 unit, this 1 unit, this 1 unit. And let's join this hypotenuse. Again, by using Pythagoras theorem, root 2 square plus 1 square will get root 3 square. Now, let us see which center O and radius root 2 let's draw an arc. This arc will intersect the line segment at a point P. This P represents root 2 because this length and this distance will be equal. And again, with center O and radius root 3, let us draw an arc. That also which intersect at a point Q. This point Q represents root 3 because this distance and this distance will be equal. Now, the points P and Q representing what? P represents root 2 and Q represents root 3 on the number line. On a number line. But root 2 and root 3 what number? Root 2 and root 3 are not rational number. Rational number. That means there exist points on the number line not representing rational number. And so on. I think you'll understand. Now let's see question number 2. Prove that there is no rational number whose square is 3. That means how to prove this? We're going to prove there is no rational number whose square is 3. Now let's take there is rational number whose square is 3. If a rational number less than x such that what? Whose square is 3. That is x square equal to what? 3. That is, you want to find x means square become square root 3. Then, what is x? X is a rational number. Rational number is in the form p by q equal to what? Root 3. Squaring both sides, let us see. P over q here also square. Root 3 also what? Square. That means p is a p square. Q is a q square. Root 3 is what? 3. We have already learned in class 9. And now when q equal to 1 means 1 square is 1. Equal to what? 3. When q equal to 1. Now next, p square by 1 means p square equal to 3. That is, any rational number square is 3. They are not exact. Now, I'll give here 1 square means 1 is 1. 2 square, 2 is 4. There is a rational number whose square is 1 and whose square is 4. But there is no rational number whose square is 3. That means what? 3 lies between 1 square and what? 2 square. 1 square means 1, 2 square means 4. 3 lies between 1 and 4. So, first, before we take, there is a rational number whose square is 3. But when we say there is no rational number whose square is 3. That is why this contradiction method. This contradiction is due to our assumption. Hence proof. I think you'll understand. Let us see question number 3. Prove that root 5 is an irrational number. Irrational number means root 5 is not irrational. Let us take root 5 is irrational. Let root 5 be a rational number. Then rational number is in the form of p by q equals root 5. Squaring both sides, p over q whole square and root 5 also square. We know that p square downside q square. Root 5, 5, and p square equal to 1, q equal to 1, 1 square equal to 1 equal to 5 when q equal to 1. Now p square is equal to 5. Let us see, is any rational number whose square is 5? Let us check. 2 square equal to 4, 3 square equal to what? 9. So there is no rational number whose square is 5. That means 5 lies between 2 square and what? 3 square. That is 2 square less than 5 less than 3 square. So first we have taken that root 5 is a rational number. But here there is no rational number whose square is 5. That is why our contradiction is due to our assumption. This contradiction is due to our assumption. That is why root 5 is not a rational. Root 5 is not a rational means root 5 is an irrational. Hence, root 5 is an irrational number. I think you will understand. Question number 4. Prove that root 7 is not a rational. Root 7 is not a rational means root 7 is an irrational. Root 7 is an irrational means there is no rational number whose square is 7. Now let's see. Root 7 is not a rational means let root 7 be rational. Let root 7 be a rational number. The rational number means in the form of p by q equal to what? Root 7. Squaring both sides, p over q here also square, root 5 also square. It is p is a p square, q is a q square equal to root 5 is a, sorry, this root 7. Root 7, root 7, root 7, root 7 is a 7. 7. Then p square equal to, when q square equal to 1 means 1, 7. That means Q equal to what? 1. Here, P square by 1 means P square equal to 7. Let us see, is there any irrational number whose square is 7? 2 square equal to 4. 3 square equal to 3, 9. So there is no irrational number whose square is 7. There is 7 lies between 2 square and 3 square. So first we take here root 7 is rational, but at the last p square equal to 7 means there is no rational number whose square is 7. So this contradiction is our assumption. This contradiction is due to our assumption. That is why root 7 is not a rational. It's not a rational number henceforth. I didn't understand. Now let's see question number 5. Represent the following number on a number line. So this root 5, root 7, root 11, root 20, root 29, these all are what number? It is number. In question number 1, we have learned that all rational number as well as it is numbers can be represented on a number line. So this order it is number we can represent on the number line. Now let us see how to represent it is number on the number line. The first Roman number 1 is root 5. Root 5 we can represent first. We can write like that. Remove the root 5. 5 equal to. Try to find out sum of any two square numbers equal to 5. Now I'll give you 5. We can write 1 plus 4 equal to 5. 2 plus 3 also 5. Another 3, 0 plus 5, let's say. These are the two number, each sum is equal to 5. But this 2 also 3 also not square number. 0 and 5 is square number, not square number. But this 1 plus 4, 1 is a square number, 4 is a square number. We can write 4 plus 1 equal to 5. What is the square of 4? 2 square. What is square of 1? 1 square. 1 is 1. So now, in order to represent root 5 in the number line, first you take x or x dash. This root 5 is positive or negative? Positive. Positive means we have to write 0 right side. 0 left side is negative. This right side will take. Now first we'll take 2 units. 2 units 0, 1, 2. This will be 2 units. As you understand? And then 1 perpendicular is 1 unit. It is this perpendicular, let's take 1 unit. But this 1 unit is perpendicular to the x axis. By joining this, let's join this. So if you join by using Pythagoras theorem, we can write here is 2 square. 2 square part of what? Plus what? 1 square. Equal to 2 is 4, 1 is 1. 1 plus 4, 5. Then hypotenuse square become square root. That will come. So this distance equal to root 5. I think you will understand. Now, with center O and radius root 5. Let us draw one arc. Which intersect at the point what? P. This P represents root 5 on that number line. We can write here. The point P represents what? Root 5 on the number line. Next question, let us see. root 7. Root 7 can be represented like that. Like before, let us see sum of two square numbers equal to 7. Now I will see 7 is equal to 1 plus 6 also 7, 2 plus 5 also 7, 3 plus 4 also 7. And then 0 plus 7 also 7. Square number. This is not square number. This is not square number. This is not square number. This 4 is square number, but 3 is not square number. So we can write like that. 7 can be written as, how to write? Root 3 square plus 4 square is what? 2 square can write it. Let me see. 2 will cancel 3. 2 2s are 4. 4 plus 3, 7. So 7 can be written as, root 7 can be written as root 3 square plus 7. Now this 7 can write like that. 7 equal to what? Root 3 square plus what? 2 square. Do you understand? Now first let's construct root 3. Root 3 construct means here base partial right 1 unit and perpendicular also we take 1 unit. But this is perpendicular here. And joining this will become 1 plus 1, 2. This become root 2. Again, this base, let's consider base root 2 and perpendicular, let's take 1 unit. But this is perpendicular here. And let us join this hypotenuse. Then root 2 square plus 1 will become root 3 square by using Pythagoras theorem. So this one I'll show here. I can show here. By using Pythagoras theorem, what will come? Hypotenuse square equal to what? Base square plus perpendicular square. Base how much? Root 2 square. Perpendicular how much? 1 unit. Root 2 2 is 2, 1 is 1. 2 plus 1, 3. Then here we can find hypotenuse. Hypotenuse 5 means square become square root 3. That's why hypotenuse equal to root 3. Now this one is root 3. Root 3 plus what? 2. And here this is root 3. Base let's take and perpendicular let's do 2 units. 2 unit means this 1, 2. Up to here, 2 unit will take. Now let us join this. Now with center, then by using Pythagoras theorem, root 3 square plus 2 square equal to what will come? Root 7. Very easy, you understand. Now with center O and radius, root 7, let us draw an arc. This arc would intersect at a point P. This P represents what? Root 7 on the number line. Do you understand? Now let us write the point P represents what? Root 7 on the number line. Do you understand? Next, let's see question number 5, Roman number 3, root 7. Root 7 also is number. How will you represent root 7 on the number line? Let us see. First, as before we take, sum of two numbers equal to 11. Let's find out first. That is 11 equal to what? 1 plus 10 equals 11. 2 plus what? 9 also 11. And 3 plus what? 8 also 11. 4 plus 7 also 11. 5 plus 6 also 11. These are sum of two numbers equals 11. From here, others all cannot take, but this one we can take. 9 is square number, 2 is not. 4 is square number, 7 is not. Oh, sorry, this one 3, okay. Sorry. 3. 4 is a square number. 3 is not. This we cannot. We can use this. How to use this? Root 7 can be written as root 2 square. 11 can be written as root 2 square plus what? 3 square. There is root 2 is a 2. 3 is a 9. 2 plus 9, 11. So first we'll take root 2 and next 3 we need less than. Now, this is positive rational numbers. That is why we have to take 0 right side. 0, 1, 2, 3, 4. Let us take. And first we're going to construct what? Root 2. Root 2 how to construct? We have learned in the introduction. First base you take what? 1 unit. Perpendicular also you take 1 unit. But this is perpendicular. Now 1, 1, hypotenuse become what? Root 2. I think you understand. Very easy. Now root 2 in what will plus 3 unit. 3 unit we have to take. 3 unit. Up there's 1 unit. You can understand? 1, 2, 3. 3 unit there. This is what? 3 unit. Now by using Pythagoras theorem, we will know that hypotenuse square is equal to what? Base square plus hypotenuse square. Base square how much? Root 2 square. Hypotenuse square how much? Root 3 square. Root 2 is a 2. 3 is a 9. 2 plus 9, 11. Here, hypotenuse minus square become square 11. So this hypotenuse is what? Root 11. Now, which center O and radius root 11? Radius root 11. Let us draw one arc. These arc will intersect at a point P. This P represents what? Root 11. Finish. Let us write the point. P represents root 11 on the number line. I think you will understand. And now, exercise 1.1, question number 5, Roman number 4, root 20. Root 20, when you say 20 is equal to 1 plus 19, 2 plus 19, 3 plus 17, 4 plus 16, 5 plus 15, 6 plus 14, 7 plus 13. These all are sum of two numbers equal what? 20. In this number, the sum of two square numbers equal 20 is 4 and 16. Because 16 is a square number, 4 is a square number. Let us take 20 equal to 16 plus 4 equal to 20. What is square of 16? 4 square. And 4 square is 2 square. Now base will take 4 units. 0, 1, 2, 3, 4. Here will take 4 units. And perimeter will take 2 units. 1, 2, 2 units. Now by using Pythagoras theorem, base square plus perimeter square equal to hypotenuse square. 4 square, 4, 4, 16. 2 square, 2 to 4. And hypotenuse 5 means square becomes square 20. So this hypotenuse will take what? Root 20. Now, which center O and radius what? Root 20. Let us take. And now, when I draw this arc, it will intersect the point P. This point P represents root 20 on the number line. So the point P represents root 20 on the number line. Let us see again Roman number 5. Roman 5, let's see. Roman 5 is 29. Sum of two square numbers equal to 29 is, when we set out, we will get 29 equals 25 plus 4. 25 is a square number, 4 is a square number. You understand? Then what is square of 25? 5 square. 4 square is 2 square. Now base will take 5 square. 1, 2, 3, 4, 5. Base will take 5 units. And perpendicular how many will take? 2 units. 1, 2, 2 units. Now join this by using Pythagoras theorem. 5 square, 25. 2 square, 4. That means hypotenuse become what? Root 29. Now, which center O and radius root 29? Let us draw an arc. This arc will intersect at a point what? P. This P represents root 29 on the number line. Okay, you'll understand? Now let us write the conclusion. The point P represents what? Root 29 on the number line.